Okay, so I can draw a 1, a 5, a 10, or a 20 for my first draw. But if I draw a 1 the first time, I don't have any 1s left. So what can I draw for the second draw?
5, 10, or 20.
5, a 10, or a 20. If I drew a 5 first, what can I draw for the second draw?
A 1, 10, 20.
A 1, 10, or 20. If I drew a 10 first, 1, 5, 20. If I drew a 20 first,
1, 50,
perfect. And then draw your sample space. My sample space goes like this: 1, 5, 1, 10, 1, 20, and so forth. Find the rest of them. Remember, this is it. I'm just drawing twice. That's it. Right? Set of trees for what? For the first draw. Set of trees for the second draw. Done. Just 2 draws. Now write down all your sample space. And your sample space. Sample space? Good. You guys have your class out of
Yeah.
Yes. Yeah, my hip was wrong. Sorry.
Oh, you're in Tracy, right? That's Tracy here. That's Tracy's mom.
All right, everybody good? Okay, so let's take a look at the addition rule. So this is the other thing we went over last class. We went through the addition rule for probability. 2 events that are mutually exclusive. In other words, there's nothing in common with them. They cannot occur simultaneously, right? So rolling a 3 and rolling a 4, those cannot occur simultaneously. Those are mutually exclusive. If you have 2 mutually exclusive events, you just add their probabilities, right? Like, can you be a black lab at the same time be a yellow lab? No, those are mutually exclusive. So you just add their probabilities. If they are not mutually exclusive, in other words, they can occur at the same time. So if you're a yellow lab and you're a female lab, can you be a yellow lab and a female lab at the same time? Yes. So that's different. Then you add their probabilities, but then they have overlap, right? The yellow female labs. You have to subtract the overlap, the yellow and female. So if they're mutually exclusive, that affects the addition rule. That's why I bring it up. And what that means is that you have an overlap that you have to subtract. And again, that refers to the same occurrence. Right, we're not talking about the addition rule only applies to the same occurrence. It cannot apply to different occurrences. For example, if I flip a coin 3 different times, what's probably I flip a coin and I get heads? 50%. Yeah. What's probably I flip a coin, a second coin I get heads? 50%. What's probably I flip a third coin and get heads? 50%. So it's probably that one of them is, you cannot use the word or with 3 different coin flips, 3 different events, because you get 50% plus 50% plus 50%, 150% chance. That's not possible. Right? So or only applies to a single event, one single event. Does that make sense? Now the event could theoretically be rolling 3 dice or flipping 3 coins, but then that probability is going to be adjusted, to those probabilities. Okay. All right. So let's take another quick problem from number 5. Again, this is, I think it may be on your homework. I may have gotten smart and deleted it, but I may not have. So in case I didn't, are mushrooms and pepperoni, are those mutually exclusive or not? Talk to your neighbors, 15 seconds. Are pepperoni and mushrooms mutually exclusive or not?
I don't think they are.
Yeah, it doesn't specify.
I think that's correct. So you can both say that.
Okay, what do you guys think? Who has an answer? What do you guys think? Are they mutually exclusive? Yes or no? No, they're not mutually exclusive. Why? You can have them both at the same time. You can have a pizza that they can occur at the same time. You can have a pizza that has mushrooms and pepperoni. Good? Okay, so probability. So the easiest way to do this one, if you get it on the homework, is to draw a Venn diagram. So here's my Venn diagram. The red is mushrooms. The blue is pepperoni. Okay, so, and they're saying that the probability of all of these, that you get one or the other, is 0.63. They're purple, right? They're also saying that the probability of mushrooms only, so if your homework says only, then that doesn't mean the red thing, which is what I thought it said. Because that's not right. It says only, so that means it's just this part here. So this part is 0.338. Pepperoni only is this part here. That's 0.16. All right, so how the Venn diagram works is mushrooms is the red circle. This little partial crescent is the mushrooms only part. The other little partial crescent over here, the blue little partial crescent, that's the pepperoni only part. And the part in the middle, that little tiny sliver in the middle, that's mushrooms and pepperoni both. So that's what we're trying to find. But we know that this plus that has to equal 63%, right? So we can just take them and subtract. So I would just go 0.63 minus 0.38 minus 0.16, and I'll get 0.09. So 9% is what goes in here. So this would be 0.09. 9% would be both. Good? So if you get this on your homework, this is my suggested solution and your way to solve that. Generally speaking, your textbook's very good at help buttons. For chapters 4.3 and 4.4, do not use the help buttons. They will confuse you. They do it, I think, in a much crazier, more complicated way than I do it. So don't do it that way. Just refer to my notes or ask us in class, ask any of the tutors, right? And they can help you. If you get a problem and you're stuck Sunday night and you're trying to solve it, you can also email me. I'm usually available via email, totally fine. I may not get back to you right away. I will try. So the earlier you do it Sunday, I would say try to do it Saturday if you can, because then you can email me sooner and I can get back to you, and we can email back and forth. Or you can try last minute, maybe set up an hour with one of the tutors to go over it, maybe Sunday night or something like that. Possibility. Yes. Yeah.
I'm here.
Exactly. So email her and say, hey, you got some time on Sunday to Zoom with me? Yeah.
Oh, I was just going to say, how come you don't add mushrooms and pepperoni to find 0.54? Why
You can do that.
It's the same thing.
Yeah, this is the same thing. You could have added those and subtracted from 0.63, you still get 0.09. Either way, I just didn't want to do another step of adding. I just wanted to subtract twice. Yeah. So you totally could have done it that way. That's the same thing. This is 54%. Right, 38.38 plus 0.16. So you could just subtract them all at once in one swoop. You could totally do that.
Wait, so what is the 0.63 telling us? Mushroom or pepperoni?
0.63 is mushroom is the big circle. So the 0.63 is this guy right here, the big circle that includes everything.
Okay.
It's all of it.
Oh, okay.
So this is the 0.63, this part here. Does that kind of make sense?
Right, okay. I was thinking
Yeah.
it should be 100 or something.
No.
Okay.
Mushroom or pepperoni. Because some people got neither, right?
Right.
So that's a good question. So this is 63%. What happened to the other 37%? They did not get any mushrooms or pepperoni. They're like, none of that. Right? They got sausage, or they got cheese, or they got something else. Okay. All right. Let's take a 10-minute break. We'll come back at 6:15. So one thing I was talking about with Victoria was how she felt like she learned a lot more last semester because she was explaining to people in her group, right? And that's the thing that's kind of nice is that as you explain things to each other, you'll get it more. right? So the people who are actually taking a role and explaining to other people, they're really going to learn it. But it's also good, like, the people who are, because you're working in small groups, you guys can all kind of help each other along. Does that kind of make sense? So that's kind of one of the things I really like about the in-person is that it's a lot harder to check out, right? So at any rate, oh, sorry, I totally jumped ahead here. We are on this one here, mutually exclusive puppies. Okay, so there are 20 lab puppies in the store. Which of the following below are disjoint? In other words, which of the following below are mutually exclusive? So take a second with your neighbors. This is not on your paper, so don't go looking on your paper. It's not going to be there. Just take a second and look through these four. Take 30 seconds to try to figure out which one of these are mutually exclusive and which ones aren't.
Well, male and female are. And then all the colors are also mutually exclusive.
Yeah, color and
Like from each other.
So black
I think really
All right, bring it in. What do you guys think of the first one? Male or chocolate?
I'm out.
Male and chocolate, or male or chocolate? Are those two variables mutually exclusive or not?
Yes, no, yes.
They are not.
Oh, no.
Why are they not mutually exclusive?
You can have your health.
They can happen at the same time. So that's mutually exclusive. They can happen at the same time. So those are not mutually exclusive. Will I ask you a question like this on the exam? 100%, yes. Absolutely. How about black or yellow? Are those mutually exclusive?
Yes.
Yes. Why? It can't happen at the same time. You can't be a black lab or a yellow lab at the same time. It's like eye color, right? Or hair color. You get someone, if you put a yellow lab and a black lab and they mate, the offspring is either going to be black or it's going to be yellow. It's not going to be both. It's like I said, it's like eye color. It goes one way or the other. Okay, so this is mutually exclusive. How about female or black? No, because you can be both. How about yellow or female? So this little thing here, this little U symbol, that means or. That's another way of writing or. That's the symbolic way of writing or. So it can be a yellow or female lab. That's not mutually exclusive because you can be both at the same time. Good? All right, so now at the bottom of one of your pages, we're talking about, I'm going to talk about ors and ands. Because these are important for you all to understand the difference between them. So this is, let's see, page 1, 2, 3, 4. Oh, bottom page 4. In little boxes, right? Good? Okay. So or is the union. This is the symbol. It's like a U. The union. That means that it's everything. It's both groups. When I see this symbol, the way I remember the symbol is I like to think of a man standing there with his arms open saying, I take everybody. Right? So it's just like this. He's like, you're welcome, I take you all. Right? Or all the groups. Everybody's welcome, everybody's included. So I just draw my little thing, and you can draw yours in here too. You should be drawing something in here. Just like that. That's my little guy. This is what it looks like. You should also draw this in. This is what it looks like in terms of Venn diagrams. The union is all of it. If you were an A or B, then this is, it takes all of you, everything, mushrooms or pepperoni, it's the whole thing. All right, one, the other, or both. Good? And is the intersection. That's the upside down U, kind of. So it's more restrictive. I like to think of it like the bow-legged cowboy. He's got one leg in A, he's got one leg in B, he's in both. Does that make sense? Right, so I'll show you guys what I mean. So, bow-legged cowboy, one leg in A, one leg in B, he's in both groups. So this is how I draw him. He gets drawn like this. He's got one leg in each group.
What about his hat?
Yeah, it's okay. All right, so it's the intersection. So this is the Venn diagram part for that. And is only this little bit there. That's it. And you have to be in both. It's just this little bit there. So and is just a little bit. And does not mean you add them together. And means it's just that small amount. What do we find that where you add them? Or means add. So you need to know this. Or means add. And means multiply. And we're going to go through that a lot. Did we go through a lot last semester? So everyone say it with me. Or means add. Ready? 1, 2, 3.
Or means add.
Perfect. And means multiply. Ready? 1, 2, 3. And means multiply. If you know those two things, it's going to put you in much better shape for the exam. If you don't know them, you're going to be in seriously bad shape for the exam. You need to know that. It's really important. And if you look at the rules, right? Addition rule, or means add, right? And we're gonna look a little bit at the multiplication rule in just a few minutes. But first, I want to talk about. Well, I'll show you guys. I guess I won't show you. Oh, here it is. Right, the multiplication rules, right? And means multiply. But we'll get to that in a moment. First, I want to talk a little bit more about the multiplication rules in general. So, I believe we kind of covered, okay, so the next page, we kind of covered it already on the next page, middle of the next page, right? Two events A and B are independent events. But the fact that A occurs does not affect the probability of B occurring. All right, we covered that last class. And this whole idea that independence has to do with probability, whether or not probability changed. You guys remember that was the one I pulled the king of hearts out of the deck, right? And I said, does knowing it's a heart change the probability change whether or not the probability of being a king? Yes, because if I pull a king of hearts out, there's 0 chance of that. So then king of hearts would be dependent. And then also we talked about drawing cards, right? Probably drawing an ace, 1/5. If you replace it, then it's still 1/5. It's independent. But if you keep the card and do not replace the card, again, replacing means you put the same card back in, then all of a sudden the probabilities change and it's dependent. So anytime the probabilities change, it's dependent. If the probability stays the same, doesn't affect it, it's independent. All right, so I flip a coin and roll a die. So here's a die, right? 1 dice. What's the probability I roll a 4? 1/6. Write it down. Everyone write it down. Or no, don't write it down. You don't have to write it down. Okay, I'll write it down. How's it sound? Probability of rolling a 4 is 1/6. Good. Now, I'm going to flip this coin. I flip the coin, and it's a heads. Now that I flipped the heads, what's the probability that I roll a 4? Still 1 out of 6. Everybody with me? So the probability of rolling a 4, given that big line straight up and down, given I rolled a head, I flipped the heads, is still 1/6. The probability does not change. So, is rolling a die and flipping the coin, is that dependent or independent? They're independent. Independent. They don't bother. They don't affect each other. Notice I am not comparing the probability of rolling a die and the probability of getting a heads. What's the probability of getting a heads? 1/2. Yeah. Should those be the same?
No.
No. That has nothing. I'm not comparing them. I'm saying the probability of rolling a dice, rolling a 4, with the probability of rolling a 4 given heads. So the things I'm comparing is the probability of rolling a 4 both times. It's just the first one is given nothing, probability of rolling a 4 given nothing, compared to the probability of rolling a 4 given heads. Is everyone understanding that? Should be carrying apples and apples. Should be probability of rolling a 4 both times. Just one is given nothing, and the second one is given heads. Okay. So it's going to come up again in a minute. So, I'll do this one with you guys. This is your lab number 7. I'll do the first one with you. Chocolate and male. So does knowing it's male give you any information about whether that's chocolate? So I'm going to find the probability that it's chocolate, given nothing. And compare that to the probability that it's a chocolate lab, given it's a male puppy. So find those 2 probabilities. Everyone find those 2 probabilities. Find them both. Write them down. Probability it's chocolate is what? 8 out of 20. That is 0.4. What's probability it's chocolate given it's male? Given it's male?
That's half.
Yeah, 6 out of 12. 0.5. Are those the same? No. So knowing that it's a male puppy, all of a sudden increases your chances you get a chocolate lab. Does that make sense? Please note this is not I'm not talking about all puppies in the world. I'm only talking about this sample. This only applies to this sample. If I had a different sample of puppies, I went to another rescue with another set of puppies, then different rules will apply depending upon the makeup of the puppies they have there. Does everybody understand that? So when I say this and I say, oh, blah, 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 don't say, well, it's independent because whether you're not or a man does not affect whether or not you eat broccoli. I'm not talking about that. I'm talking about in the sample I give you. Is everybody getting that? So the question I asked you in class is going, in the exam is going to be dependent upon the sample I give you in that sample. Okay. So you guys work on this one. Find those. Oh wait. So the last one, were those independent or dependent?
Dependent.
Dependent, right? The probabilities change. Okay, good. Next one. Okay, check with your neighbors because I'm going to randomly call on somebody in 15 seconds, 30 seconds.
Yeah.
4, 5, 6. First row is in a row. Okay. Michaela, what's the probability that they're female? What's the probability that we pick someone that's female?
It's
800%? 800% chance.
Okay,
Is there an 800% chance I pick someone who's female? Check with the neighbors. 15 seconds. Check with the neighbors. Everyone check with the neighbors. I'm randomly going to pick somebody. Randomly pick someone for the next 2. Okay. Michaela, do you have the answer? Okay, but how'd you get that? 8 out of what? 8 out of 20. 0.4. Good. Zora, what's probably that they're female given that they're yellow?
4 out of 6.
4 out of 6. 0.67. So, guys, are they dependent? Is yellow and female, are they independent or dependent? Dependent. Okay, so you have to pick, again, the same probability. Probability of female, and compared to probability of female again, but female is given something, given yellow, to check between yellow and female. I'm not going to give you these prompts on the exam. I'm just going to ask you, are female and yellow independent or dependent? And why? So for you to answer that question, you're going to need to, here's the easier way. How do you find these ratios? Everybody look at the table up there and figure out what has to do with female and yellow. Someone give me one number. Oh, I'll roll my dice. Roll 5, number 4. So number 4, bump, bump, bump. Nathan, give me one number that has to do with yellow or female.
So like any number?
Yep.
A 4?
4. Yep. Because there's 4 yellow females. So everyone see that one?
Mhm.
Okay. Rohan, give me another one. That's with yellow or female or both.
Both.
Well, what else has to do with yellow?
Oh, the males.
Yeah, but then that does have to do with female. So, how? I'll give you this one. How about? Okay, so the total yellows, right? So then what's another one that has to do with males, or that has to do with females?
The total.
Which is what?
8.
Yep. And then the last one is the grand total, 20. So this makes a rectangle. Does everyone see that? And it's going to make a rectangle between whatever things you're talking about. Because it's going to be the thing you care about, yellow females, and then the total for females, the total for yellows, and the grand total. You circle those 4, and then I just have to do 4 divided by 8, 6 divided by 20, and say, is 4 over 8 equal to 6 over 20? Or you could go the other direction, and you could do it like this and say, do you guys see what I'm saying? I'm doing 4 over 6. You guys understand what I'm saying when I do that? Is 4 over 6 equal to 8 over 20? So you can take those 4 and take them either way. Either take them this way, right? 4 over 6 equal to 8 over 20, or you can take them sideways and do is 4 over 6 equal to 6 over 20, right? You can do it either way. And where does this come from? Because that's when it's going to be 4 over 6 is female given yellow, and 8 over 20 is female. The other way, the 4 over 8 is yellow given female, and then yellow given nothing. So that's how you get, either question that, and that works, because you either care about female compared to female given yellow, or yellow compared to yellow given female, and those are those two. Those are those two. Everyone following? So on the exam, I will ask you the question, and this should be your answer. Dependent, and when I say why, you'll say because 4 over 6 is not equal to 8 over 20. Done. That's all I care about. You give me that, and you've shown me that you found the correct proportions, and you know what you're talking about. Yes?
So if they were equal, it'd be independent.
Yes. Okay, so in that name, I want you guys, again, if they were equal, then you'd say they're independent because 4 over 6 equals 2 over 3, whatever. Good? Okay. So why don't you guys do one more? Flip the page, you got one more to do.